Okay, so we were as far as here, sorry, but I noticed I made a mistake there. When I put it over a common denominator, that should be 1 into 1 into 2 goes twice, 2 ones are 2. So that should be a 2. Okay, sorry about that. Okay, so we get 1 plus 2 plus 3 all the way up to k plus 1, right, equals, factorize here, we have k and k, 2 and 1 and a plus and a plus, so they're my factors, over 2, and guess what, that equals to that, doesn't it? It's just written in it, so that's the same as my to prove line. Okay, there's the k plus 2, there's the k plus 1, and there's the over 2. It doesn't, over 2 doesn't matter where it is, okay, right? So therefore, then you write your conclusion. So the same conclusion for every single one of these sums. You make 4 statements. You say it's true for n equals 1. It's true for n equals k. You say it's true for n equals k plus 1. So because you've proved it's true for a random number, and then for the next number you can say therefore 3 dots means therefore, girls, therefore it's true for all n element of n where n they're natural numbers, as in term number 1, 2, 3, 4, 5, 6, 100, whatever. Is that alright? Okay, so that's your conclusion. Okay, there's a bit to it, okay, but we'll get there, okay, but there's very clear steps, okay. Right, okay, ready for a second example? This conclusion I'm going to keep the board for the next one because it's, you write the same 4 lines at the end of every one, okay? So, can I take it away? Yeah, okay. Okay, example 2, right? So I need to prove that for all values of n, element of n, that 3 plus 3 squared plus 3 to the power 3, so 3 to the power 1, 3 to the power 2, plus 3 to the power 3, plus all the way up to 3 to the power of n is equal to 3 over 2 times 3 to the power of n minus 1. Okay? Sorry, I need to, while you're writing that down, I'll just freeze the screen a sec. Right, if you just give me a sec, I need to take a picture of this. Sorry, I'm coming. Okay, right, okay, this one, right, okay, so step 1, prove it's true for n equals 1. Sorry. Prove it's true for n equals 1. Okay, so n equals 1 means the first term on this side. So the first term on this side is 3, and on the other side everywhere you see an n, put in a 1. 3 over 2 times 3 to the power of 1 minus 1. Okay, and into the calculator with that, and you'll get 3, and that's true for n equals 1. Okay, then you need to assume it's true for n equals k. So that means 3 to the power 1 plus 3 to the power 2 plus 3 to the power of 3 plus dot 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 all the way up to 3 to the power of k is equal to 3 over 2 times 3 to the power of k minus 1. Okay. So then you need to prove it's true for n equals k plus 1. So that means I'm trying to prove that, and remember n equals k plus 1 is the next term up. So it's 3 plus 3 squared plus 3 cubed plus dot 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 all the way up to 3k, but then plus 3 to the power of k plus 1. I'm trying to prove that's equal to 3 over 2 times, instead of k I put in k plus, or instead of n I put in k plus 1 minus 1. So that's what I'm trying to prove, so that should be my last line. Okay, so this is what I'm trying to prove. This is what I know to be true. So there's the first line of my proof, there's the last line of my proof. Okay? Right, so okay, so now I'm on to my proof. So as I say, the first line of your proof is always your assumption. So it's 3 plus 3 squared plus 3 cubed plus dot 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 all the way up to 3 to the power of k is equal to 3 over 2 times 3 to the power of k minus 1. So that's, I know that to be true, so I need to turn this line into this line. Okay, so I look and I say, well look, I can make the left hand side equal if I add 3 to the power of k plus 1 to both sides. Okay, so that's 3 plus 3 squared plus 3 cubed plus 3 to the power of k plus 3 to the power of k plus 1 equals 3 over 2 to the power of 3k minus 1, and I have to add a 3 to the power of k plus 1. Okay, so I have turned the left hand side is now equal to the left hand side. Now I have to play around with the right hand side to make it look like this. Okay, so I have to play around with this to show it's the same as this. Okay, right, so off I go. So 3 plus 3 squared plus 3 to the power of 3 dot 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 plus 3 to the power of k plus 3 to the power of k plus 1, right, equals wait, now let's see what's the best way to proceed with this. Yeah, there's a short way and there's a kind of an easier way to understand. So the short way will come to you. The easier way to understand is more important at this stage. So what I might do is 3 to the 3 like that. And yeah, I'm going to multiply in 3 by 3 to the power of k minus 3 all over 2 plus 3 to the power of k plus 1. So I just multiplied in there, okay? Okay, and now I'm going to get a common denominator. So is it okay that I don't write out all the left hand side again? So the left hand side stays the same, all over 2. I go 2 into 2 goes 1, so basically everything on top there stays the same. Minus 3 plus, that would be 2 times 3 to the power of k plus 1. Okay? Right, okay, that would be over 2, that would be 3 by 3 to the power of k is, that's 3 to the power of 1 by 3 to the power of k, which would be 3 to the power of k plus 1, right, minus 3 plus 2 times 3 to the power of k plus 1, okay, right. I can put the 3 to the power of k plus 1s together. There's 1 here and there's 2 here. So that means there's 3. It's like x plus 2x would be 3x. Right? So 3 to the power of k plus 1 plus 2 times 3 to the power of k plus 1 is 3 times 3 to the power of k plus 1 minus 3 all over 2. And then on top, guys, I'm going to take out a 3. There's a 3 common. So I'm left with 3 to the power of k plus 1 minus 1 all over 2, which is what I'm trying to prove. Okay, so if you look back up at the prove line, that's just written in a different form. Okay, so that's job done. So then you write the 4 sentences that I'm cheating, right, and you say, well, it was true for n equals 1. It was true for n equals k. It was true for n equals k plus 1, therefore it's true for all n. Okay, so say 4 lines at the end of every sum. Okay? Right, I have a third example, but before I do it, can I take this away? Before I do it, I wanted to talk about this sigma notation, right? Okay, so we've seen it in sequences and series, but just to remind you, that means the sum of. Right, okay, so if I had the sum of n from n equals 1 all the way up to n. That's a short way of writing. You start with n equals 1, then you add n equals 2, then you add n equals 3, then you add n equals 4, and you keep adding it all the way up to n. So basically that's a short way of writing this. Okay? Something like the sum of from n equals 1 up to n of n squared. That would be, put in 1, it would be 1 squared. Put in 2, it would be 2 squared, which is 4. Put in 3, be 3 squared, which is 9. Plus 4 squared is 16, etc. all the way up to n squared. Okay, so before I do the last example, I'm just telling you that this here is a short way of writing out like this series here. Okay, so the sum of, is that okay? That symbol just means you start filling in n equals 1, then you add n equals 2, then you add n equals 3, right? Okay, so you n equals 1, n equals 2, n equals 3, etc. Okay, so that's all that symbol means. Okay, because you see it sometimes in these sums. Okay, example 3, I'm going to go for a third example, and I'll leave you go then. I know it's going on a bit this morning, but I have lots to get through. Okay, so can I go for example 3? Okay, so example 3 is 1 all over, now this is 1 multiplied by 2, add 1 all over 2 multiplied by 3, add dot 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 1 all over the number multiplied by the next number. So it could be 3 multiplied by 4, 1 all over 4 multiplied by 5, 1 all over 100 multiplied by 101. Okay, so that's the same as n all over n plus 1. That would be the same as n all over n plus 1. Right, okay, so off we go. So we prove it's true for n equals 1. So n equals 1 is just the first term. N is the position of the term, so the first term. So that's 1 all over 1 multiplied by 2. Now that's not 1.2, it's 1 multiplied by 2. Does that equal to 1 all over 1 plus 1? So on this side you get 1 over 1 multiplied by 2 is 2, and over this side you get 1 over 2. So that means it's true. That's a true statement. So you've proved it's true for n equals 1. Right? You assume it's true. For n equals k. So that means, and the next statement is a true statement, so it's going to be the first line of your proof. So that's 1 all over 1 multiplied by 2 plus 1 all over 2 multiplied by 3 plus dot 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 1 all over k multiplied by k plus 1. Right, that would be equal to k all over k plus 1. Okay, so that's a true statement, right? Okay, I'm assuming it, but as far as I'm concerned, that's a true statement. So that's going to be the first line of my proof, right? Okay, so I need to write down what I need to prove. Right, now I need to prove it's true for n equals k plus 1. Right, okay, so let's just write down what I'm trying to prove. Remember, k plus 1 term is the next term up. So this is up as far as k plus 1 is the next term. So I'm trying to prove that 1 all over 1 multiplied by 2 plus 1 all over 2 multiplied by 3 plus dot 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 1 all over k multiplied by k plus 1 plus next one up would be up 1 from k would be k plus 1, and up 1 from k plus 1 would be k plus 2. Right? And over here, instead of n, I'm putting in a k plus 1. So it's all over k plus 1, all over k plus 1 plus 1. As in n all over n plus 1, which is k plus 1 all over k plus 2. So that's my to prove line. This is my answer. This is what I want to end up with on the right hand side. Okay, so proof. So we start off with our true statement. So your true statement is your assumption. So 1 all over 1 multiplied by 2 plus 2 multiplied by 3 plus all the way up to 1 all over k times k plus 1 equals k all over k plus 1. So that's my true statement that I made there. Okay, that's the first line of my proof. Okay, then you look at your first line of your proof and you look at the last line of your proof and you say, well, how am I going to go from this line to this line? Okay, so you notice, well, the left hand side has this bit added onto it. So what I'm going to do is I'm going to add that bit to both sides. So you add 1 all over k plus 1 multiplied by k plus 2 to both sides. So can I move it up? Would that be okay? Have I cut anyone off? Right. So basically my left hand side I have 1 plus 1 by 2 plus 1 all over 2 by 3 plus dot 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 1 all over k times k plus 1 plus what I'm adding to both sides 1 all over k plus 1 multiplied by k plus 2, and I take the right hand side, which is k all over k plus 1, and I add on the exact same term, which is 1 all over k plus 1 times k plus 2. So my left hand side looks how I want it to look, right? My right hand side, I need to play around with it so that it looks like k plus 1 over k plus 2. Okay, so my right hand side is exactly as I want it. So 1 plus dot dot dot, I'm going to leave out most of writing those down. K plus 1 times k plus 2. Okay, so I just didn't write down the middle ones there, right? Equals, over this side, I need to manipulate this so it looks like this. So it's a fraction and a fraction, so let's get a common denominator, as you would in any branch of maths the minute you see fractions. So my fraction is k plus 1 multiplied by k plus 2. So it's this multiplied by the k plus 1 is there already and the k plus 2. So you go k plus 1 into k plus 1 times k plus 2 goes k plus 2 times. So it's k, it's already above the line, and it goes in k plus 2 times. Right? And all of that goes into all of that once, so it's 1 multiplied by 1. Okay? Right? 1 all over 1 multiplied by 2 plus dot 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 1 all over k plus 1 times k plus 2 equals, multiply out on top. So on top I have k squared plus 2k plus 1 all over k plus 1 multiplied by k plus 2. Sorry, I need my board. So, right, on this side I have 1 multiplied by 1 multiplied by 2 plus dot 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 1 all over k plus 1 multiplied by k plus 2. Right, over this side I can factorize on top. So I'm factorizing on top, so I have 2 brackets, k and k, 1 and 1, a plus and a plus. Underneath the line I have a k plus 1 and a k plus 2, and look at that, one of the k plus 1's cancels and I'm left with k plus 1 over k plus 2, which is what I wanted in my to prove line. So looking back up at my to prove line, that's exactly what I wanted. Okay, so I should probably just write one more line just to plus that 1 all over k plus 1 times k plus 2 equals k plus 1 all over k plus 2. So the last line of my proof should be my to prove line, and it is. Okay, and then you write your 4 statements. Okay, so your 4 statements are, it's true for n equals 1, it's true for n equals k, it's true for n equals k for plus 1, therefore it's true for all n element of n. Right, okay, so these are all on page 500. Okay, and I'm going to ask you to do numbers 1 to 5, so 5 of them for homework. Okay, so page 500, 1 to 5. Okay, and please have a go with them and make sure you can do them, because as I say, I have to move on to the next type tomorrow. There's 3 types. Okay, So page 500, 1 to 5. And can I move that up like that so you can see this? Right, okay. Are we all, yeah, you've all left probably, there's no one out there. I know there isn't. It's fine, I'm happy to talk to myself. Right, sure, look, I'll put up the videos online. They're in 3 bits. I'll put up the videos online anyway, and you can have another look at them if it helps, right, okay? Right, and if not, I'll see you tomorrow, okay? So you can head off when that's down, okay?
Thanks.
Right, bye now, talk to you tomorrow.